All right, guys. So I am going to be going over what a controlled experiment looks like. You guys are going to be watching this in class. Then we're going to come back and we'll do some practice with it. Okay. So, how would you go about supporting the statement when you exercise, your heart rate increases? So, I want you to write that down here and make sure you include a control group, variables, and constants. So, the best that you know, to your best ability, I want you to answer this question. So we use this method. It's called the scientific method. Now we don't really actually use this process in science anymore. And speaking from terms of biotechnology and actually doing these things in the lab and how we discover stuff, we don't really use this anymore, but it is a good way to get your thoughts and get a process down on paper. So, the first thing that typically happens is you make an observation. So, whether that be I feel my heart pumping out of my chest after I'm done exercising, or I'm having a hard time breathing after running for a couple miles, any of those things would be observations, right? And then after that, you're going to ask your question, you'll form a hypothesis, you can do your experiment. And then the last thing that you are going to do is you're either going to accept or reject your hypothesis. Now, in this course, when you finish a lab, we typically write a conclusion, or what you would know as a CER, not to a CER like that, but just like a conclusion of a couple sentences, maybe. And you are always going to say you either accept your hypothesis and why, or you reject your hypothesis and why. Okay, so you can either say supports your data supports, and or you accept your hypothesis, or you can say your hypothesis was not supported by your data, so you reject your hypothesis. There is no right and wrong, so I don't usually want to see that terminology, and you will lose points on your lab if you use the terms right and wrong. Okay, there is no right and wrong. It's either supported, not supported, accepted, rejected. All right. So the first step is your observation, and this is our direct method of gathering information. So we're gathering information in like a normal way, right? Just like about the world around you. You make tons of observations on a regular basis. So that's really what's going on here. So your observation about the heart rate would be when running, I can feel my heart pounding, right? Some people are out of breath when they finish working out for a long period of time. All of these things are observations or things that you see. It could be as simple as there was water droplets on my window this morning. Any of those observations or just statements about the world around you are observations. Okay. And you probably do this regularly when you're thinking about things that are going on around you. After you make your observation, you're going to ask your question, right? So your question is just going to be developed based on the observations that you make. So once you make your observation, you're going to take that observation and now you're going to ask a question about that observation. So does the length of exercise cause your heart rate to increase? Sorry, wow, that's a typo. That's awful. Okay. So does length exercise? Wow, Mrs. Martin is off today. All right. So, does the length of exercise cause your heart rate to increase? That would be a question, right? And then after you ask that question, you are going to make a hypothesis, right? And your hypothesis is not an educated guess. So, I don't want you to use that terminology, okay? It is not an educated guess. It is a prediction based on your observations. Okay. And then this prediction needs to be testable. So that means that you need to be able to collect data on it. You need to be able to set up an experiment. And that is the important part of what a hypothesis is. Okay. So if I exercise for different times, then my heart rate will increase the longer I work out. That is a hypothesis. Okay. You are making a prediction based on an observation, right? So we just said that I felt my heart pounding and people are out of breath when they are running for long periods of time. Now we're taking these observations and we're putting them into a if then statement. If being the cause, then being the effect. So now once we get into this portion, we are going to be setting up our experiment. And this is what we call a controlled experiment. A controlled experiment is the standard of what we do in this class. Okay, so when you guys are designing your own labs, which is something that we do a little bit in this course, you need to be able to have a controlled experiment. So the first thing I want you to think about is what your control group would be. So now your control group is your group that you compare your experiment to. Okay, so it would be the standard or the normal scenario, right? Now, what I want you to think about is in terms of our heart rate question, all right? So our hypothesis, if I exercise for long periods of times, then my heart rate will increase over time. What would the control group be there? So your control group there should be your resting heart rate, your heart rate without exercise, right? You're taking away that exercise portion, and that is going to give you your standard or your control group. Okay, so now that you have your control group, you're going to have your experimental group. And now this is your actual experiment. This is where you get to do all the fun stuff and you get to test your hypothesis. Okay, and your control group is made up of a couple important variables. So you have what we call an independent variable, a dependent variable, and then you have constants, okay? And all of these things make your experiment valid, okay? Without these things, your experiment will not work and it cannot actually help you support or accept your hypothesis. So your experimental group is going to be exposed to whatever factor you're testing. So in this case, it would be exercise, right? So that's the factor that we are testing. So your independent variable is what you are manipulating. So what is going to affect the outcome of this experiment. So I want you to take a second and I want you to answer what you think the independent variable in our exercise and heart rate scenario is. Okay, so our independent variable should be the time exercising, right? So if we're saying that the longer I exercise, the more my heart rate is going to increase, then that means that your independent variable is going to be the time that you exercise for, right? Because that's going to affect the outcome of the experiment. Okay, now your dependent variable is a change that results or depends on the independent variable, right? So it's dependent on the independent variable, or it's the outcome of this experiment. So it's the outcome, what we're measuring here. Now, what are we measuring? The dependent variable here is going to be your heart rate, right? So your heart rate while exercising. That is going to be the dependent variable. So some constants are factors that do not change in each trial of the experiment. So we just said if we do different trials, say we do 3 trials where you run for 5 minutes, 10 minutes, and 15 minutes, and each one you take your heart rate after. The constant would have to be, right, the things that are going to be the same between all 3 of those, right? So we know it's not the independent variable, which would be the time run, and we know it's not heart rate because we can't control that. That's our outcome. What it is going to be is it's going to be maybe the type of exercise that we do. So you could say jumping jacks for 15 minutes, or you could say running for 15 minutes, or walking on the stair stepper for 15 minutes. Any of those things, you have to pick one of them. Okay, so all 3 trials, you would have the same exact exercise going on. Another thing that could affect your experiment would maybe be the temperature in the room, right? So you don't want one trial to take place when the room is 65 degrees and then another trial to take place and the room is 85 degrees, right? That's going to be a big difference because if you've gone running before, you know that there's certain temperatures that you feel better when you run, right? You might get tired faster in 85 degree weather versus in a 65 degree weather. Another thing could be the amount of water that was consumed before running, right? So maybe the individuals are drinking a certain amount of food or the amount of, water, or I'm jumping ahead here. Or maybe it's what they ate for dinner or breakfast before they ran, right? They all ate the same thing because these things would affect their ability to produce energy, which they're going to need to run. All right, now we have our last few slides. We're almost done here. We have our data. The data is what you get from all of your hard work, right? So you just put together this experiment and now you're going to get this information. So you're either going to get qualitative or you're going to get quantitative data. Qualitative data are our five senses, right? So things that you see, you hear, you feel, you smell, you touch, right? Or you taste, any of those feelings, that's going to be your qualitative data. And now qualitative data is just as valid as quantitative data. It's not less important. All right. So you could ask after each trial, how do you feel? Do you feel tired? Do you feel your heart racing? Okay. How do you feel? And then you could say, do you see anything like specific, like are you sweating? Any of those things are all going to be qualitative data. Now, the quantitative data, right, is going to be expressed as numbers. So that's our number data. And that would be your actual heart rate. So if you stand there and you take your pulse or you use a machine, you would be able to get an exact number on their heart rate once they finish working out. And now the last thing is your favorite, I'm sure, if you wrote CERs. This is pretty much what a CER is, right? So it is an explanation of your findings or your conclusion. And you are just going to say if your hypothesis was supported or rejected using your data. So my data shows that there is no difference in the in the heart rate in each trial, right? So after 5 minutes, the exercise, the heart rate was taken, and the BPM or the heart rate was 132 per minute, beats per minute. And then after 10 minutes, it was 132. And then after 15 minutes, it was still 132, which is not probably going to be what happens. But if that were, you would say that your hypothesis was rejected because my data showed X, Y, and Z. And this disproves it because they were all the same heart rates after each trial, meaning that the heart rate did not increase with the longer time. Okay? So once you're finished with this, you can hop back on the Google Meet. And now we are going to talk a little bit about some practice with variables.